Hi everyone, welcome to this lecture. So this lecture is a part 2 of project 1. So here we will continue our project 1. So what I am going to do in the second part of the project 1. So basically I am again getting the class probabilities from my logistic regression model, but this time I am using another dataset. So this time I am generating a dataset using a function make_classification. I am importing this function from Scikit-learn.dataset. The other thing is I also need train test split, which I am importing from sklearn.model_selection. So let's run this cell to import all these necessary functions. Now here is the important thing that I am going to use a function make_classification. So what are the inputs? So there are quite a few input to this function. First of all, how many samples I need in my data set. So here I am generating a 50 samples. Then how many features I need. Here I am generating a data set with 2 features. How many of the features should be informative? So I want all my 2 features should be informative. So there should be no redundant feature in my data set. Therefore, I have passed number of redundant is equals to 0. And here number of classes is equals to 2. So I want 2 classes in my data set. So if I run this cell, I will get 2 output. That is, I will get the value of the features and I will get the labels from this data set. So if I run this cell, I will get X and Y. If I run this np.unique, so I want to see how many unique labels this dataset has provided me. So let's run this cell. So we have 2 labels, 0 and 1, because we have passed number of classes is equals to 2. So I get 2 labels. Now to check the shape of our feature, which is X, so it is 50 by 2 because we have 50 samples and we have 2 features. So the important thing is this make classification function is generating data set randomly. So every time I run this cell, I will see different values of X. So I can confirm this, that if I add another cell and I want to see the value of X, so in order to see the value of X, let me reduce the number of samples to 5 so that I can learn how make classification is producing data sample for me. So I am now creating 5 samples and here is the value of X. So you can see that here the value of X of the first feature is 0.69 and the second feature is 1.71. So if I run this again and I want to see X, you will see these values will be changed. Let's run this cell. So all these values are changed. So what is happening over here? The one thing is happening that make classification is generating data randomly. So every time I will run this function, I will get the different samples of my data. That is the different sample of my features. If I want that every time I run this cell, I want to see the same samples, I have to pass a seed which is in the form of random state. Okay, if I run this cell again, you can see if now I will run, these values will be changed. So if I want every time that same value should be produced, so I have to pass a random state, random underscore state, and I have to pass any of the values. Suppose I am passing 42 here. Now I have passed random state is equals to 42. If I run this cell now, and I will see X. So now you can see that it is 1.26 and minus 1. Now if I run this again and again, the value of X will not change and I will get the same samples. So let's run this cell again and see the value of X. Now you can see it is 1.26. Again, if I run this cell and again see the value, so we can see that it is 1.26. So now since I initially needed 50 samples, therefore I am back to my original data set and here is the random state, so that I have passed the random state for you student, that whenever you run this, you will get the same values which I get. So the random state is equals to 42. Now run this cell. And if I run this, so I have these 50 value of samples, because if I run this, I have 50 samples and I have 2 features. So this is the advantage of make classification. Every time you run this, you can get the different data set. And if you want the same samples to be produced every time, you have to pass a random state is equals to 42. So that is the description of the function make classification. Now I have my data set generated. Now it's time to perform a train test split. So for train test split, there is a function train underscore test underscore split. I have to pass my feature, my labels, test size, and random state again 42, so that every time I run this cell, I get the same feature, same samples in the training and the testing component. So when I run this cell, I will get 4 output: the training samples, testing samples, training labels, and the testing labels. Okay, now it's time to train a logistic regression on our training component. So here I am creating a logistic regression. I am instantiating my logistic regression and I am calling it a model. Here I am fitting the model on my training component of a data. Basically here I am training my model. So dot fit is used to train the model. So let's run this cell. Here I am generating the probabilities from X test. So let's run this cell. So we know from the part 1 of this project that the function used for generating probabilities is lr.predict underscore prob a. This time we have 10 samples in our test data. So these are the probabilities of the values with respect to X test. So we can see that these values are 6.17 exponent minus 2. So these are with the different exponents. So what we can do here is that we can call it round 2 so that we can see it into after 2 places of decimal. So if I run this cell, okay, now it is very clear. So we have transformed these probabilities into 2 places of decimal. That is, we need a value 2 or we need 2 values after the decimal point. So we can see that if we see the first sample, now the probability of first sample with class 0 is 0.06 and with class 1 is 0.1. It means our first test sample belongs to class 1. Now here is a very high value of the probability. So our second sample belongs to class 0. Our third sample belongs to class 1. Fourth sample belongs to class 1. So, and our last sample belongs to class 0. So these are the probabilities with class 1. The first column of this probability indicates that the probability with respect to class 0, and this belongs to class 1 because we have 2 classes. If we go back, we can see that we have classes 0 and 1. Okay, so let's confirm whether these probabilities values are correct or not. Let's get the class predictions. So we can see that the first sample belongs to class 1. It has high probability with class 1, which is also verified from the class prediction. And the last sample belongs to class 0. It has high probability with class 0. It is also verified with this. So what we can do further in order to get these probabilities more clear and get the more understanding of the probabilities and the predictions. Okay, we can create a table. We can create a table of 3 columns. So in the first column, we will have this value of the probability. In the second column, we will have this value of the probability. And in the third column, we will have prediction, and then we will compare. So I am creating a table using pd.dataframe. So I am creating the data frame using the commands pd.dataframe, where pd stands for pandas, or it is representing pandas library. So my first column name is probability underscore class 0. Second column name is probability underscore class 1. And the third column name is the predicted class. So in the first column, I am passing the first column. So if I write this y underscore pred underscore prob is to 0, so this will give me the first column. So we can confirm this. If I write a code here, y pred underscore prob 0, so what will happening? It is giving me the value of the first column, 0.01, you can see, then 1, then it is 0.0. So if I want to extract first column, so I have to pass this column. This column means all the rows I needed, and 0 means I need the value from the first column. So this is the first column of y pred underscore prob, and we know that the index in Python starts from 0. Therefore, in order to extract this first column, I have to pass 0. So if I pass 1 here, then I will get these values. The first value will be 0.94 and the last value will be 0.03. So we can see that our first value is 0.94 and the last value is 0.3. So in this way, I can get any column. That is, there are 2 columns in this probability matrix. So if I want to extract first column, I have to pass 0 here. And for second column, I have to pass 1 here. So I am doing the same here. For getting the probabilities related to class 0, I need the first column of y pred.prob. So I am passing a 0 here. And for getting the probabilities of class 1, I need the second column. Therefore, I am passing y pred underscore prob under equals to column, and this is 1. This column means I am getting all the rows, and this 1 means I am getting the second column from here. The last column name is predicted class, and I am passing these values. So let's run this cell and see the table. So we will get more understanding now because we have created the table. If you see this column, prob underscore class 0, if you see this column of the table, it has all the values related to class 0 and it has all the values related to class 1. So these values are taken from this and this value. And here is the predicted class. So we can confirm there, when the probability related to class 1 is high, our prediction about the class is also accurate. That is, when the probability related to class 1 is high, the predicted class is also 1. When the probability related to class 0 is high, the predicted class is also 0. Similarly, we can see here the predicted probability with class 1 is high, so the prediction class or predicted class is also 1. It means our model has calculated all the probability values correctly and it is confirmed with the predicted class. So in this lecture, we learn about the probabilities which are produced by the logistic regression model. We learn how to calculate the class probabilities, and we also learn how to verify these class probabilities with the help of predicted class. So that was the lecture 2 on project 1, where we again learn how to calculate the class probabilities. But in this part, we use a different dataset and we learn how we can create our own dataset using a function make underscore classification. So I hope you understood this part of the project 1 as well. Thanks for listening, and I will see you in the next lecture.